Hello everyone, it's Tasya and today I'm going to show you how to answer homework 4. There are 3 questions provided by Mr. Farid and I decided to choose 2 numbers, which are number 2 and number 3. Let's start with number 2. So we're going to start with number 2 here. In number 2, there is a beam like this with this dimension as well, and it is known that the beam is made of nylon, and the allowable stress for tension is 24 MPa, while for compression it is known to be 30 MPa. And in this question we are asked to determine the largest couple M that apply to the beam. So make sure we have written all the known values here to be able to answer this question, which is determining the largest couple M that apply to the beam. So how we're gonna answer number 2 is first by write all the known values. The figure here has the dimension that we need, and also from the question we know that the allowable stress for tension is 24 MPa, while for compression it is 30 MPa. The question is we have to determine the largest couple M. And then after write all the known values and understand the question, the second step is to calculate the location of the section centroid. How we're gonna do it is by making this kind of table which consists of the area and the y and y times area. From the figure we know that there are 2 different shapes here for the beam, so we're going to divide it into 2 figures here, and we have to determine each of the area and each of the y for each figure. How we determine y is by set the benchmark point. Here I set the benchmark point as here. So if we have to find the y in 1, so we need to measure the distance from here to the middle of figure 1. So it's gonna be y1 here, and for figure 2 is the same. We have to measure from here to the middle of figure 2. Let's say it's here, so y2 will be the distance in this. So the area for figure 1, we know that the base is 40 and the height is 50 here, and the area is just multiply those numbers. The same with figure 2, and for y is just measure the benchmark here, and then we have to multiply y and area, and then we have to sum up the area and y times area. And then to find the section centroid, we make this formula sigma ya, which is the sum here, and sigma a, or the sum of the area here. We put everything in and we obtain the section centroid is 17.5 mm. So in the next step, we have to calculate the moment of inertia. As I explained in the previous step that we define the beam here as 2 different figures, so meaning we need to find 2 different moment of inertia. And the formula for moment of inertia is 1/12 times b h to the power of 3 plus a times d to the power of 2. We have known the b and the h from the question, it is known there, and the area is obtained from the previous type, right, from the table. And the next is how we define the d. D is the distance between the middle of the figure to the section centroid here. So for D1 it is here to here, while for D2 is from here to here. Yeah. So D1 is known to be 5 and D2 is known to be 10. And we put everything into the formula and we obtain the I1 and I2. To find the total moment of inertia, we have to sum up I2 and I1. And we obtain the I1 is, sorry for that, we obtain the total I is 61.875 times 10 to the power of 3 millimeter to the power of 4. But since we are going to deal with meter as the unit here, so we need to convert it into meter to the power of 4. The next is we have to find the largest m. We know that the basic formula is sigma equal to mc over I. And here, since the known values in the question is sigma t and sigma c, meaning that we have to determine which figure is experiencing tension and which figure is experiencing compression. So let me erase this first. Okay, so in the question it is known that the moment or the couple is going downward and make the beam for the upper part here is experiencing tension, while for the below is experiencing compression here. So for the formula, sigma t is equal to m1, which is figure 1, c1 over I, while for the sigma compression it is m2 c2 over I. And we just need to change the formula to change the formula exchange between m and sigma here, and we obtain m1 is sigma ti over c1 and m2 sigma ci over sigma ci over c2. And then for c1 it is 15 minus 2.5, which is 12.5, and c2 is 15 plus 2.5, which is 17.5. Let me erase all them first. And we're moving to the next step, which is determining the m. So we know this formula. We have known this formula here. So we just need to put everything in to find the m1, m, m2. It is known that m1 that is 118.8 Newton meter and m2 is 106.1 Newton meter. So we just need to compare these two. Which one is bigger? It is obviously this one, right? So the largest couple m applied is 118.8 Newton meter. Here. So we're done with question number 2. Now we're moving on to the third question, because I chose 3, so we're gonna moving on to the third question. The question here, it is known that the wall thickness or T is 10 millimeter. T is here and here, and then the press is being glued together until P is equal to 20 kilonewton. P is 20 kilonewton, and the question asks us to determine the stress at point A, and point B. It is point A. This is point A, and this is point B. So make sure we have written all the known values before to answer the question. Okay, so we're gonna move on to the step to answer the question. Step 1, we have to write all the known values. The question provides us the figure here and with its dimension, and also we have the known values is the wall thickness, which is 10 millimeter, and the P is 20 kilonewton. And the question is we have to determine the stress at point A and also point B. And in here we also have to determine the neutral axis. We see here that the P acting on this structure is on the y-axis, meaning that we also have to set the natural axis is in y. This is the natural axis is in y-axis. Why? It is because this natural axis will change the formula like the usual thing that we know. So make sure that you set the natural axis is in y when the force or the load is acting on y-axis as well. The second step is we have to calculate the area of this. Let me erase this first. Okay, the area of this, since it is not solid, it has this wall thickness, so the area will be 80 multiplied by 60 minus, because it is hollow, so it should be minus 80 minus 20 multiplied by 60 minus 20. Why 20? It is because the structure has wall thickness 10, right? 10 millimeter. But it also has two sides here, two sides each. So 10 multiplied by 2 is 20. That's why it is 80 minus 20 multiplied by 60 minus 20. And we found the area is 2,400 millimeter square, or since we're gonna dealing with meter, so we need to convert that to meter. And the area is 2.4 multiplied by 10 to the power of minus 3 meter square. Sorry, I forgot to put square here. Okay, the third step is we need to calculate the normal stress due to centric load. Centric load here is the P. And so we define it as sigma 0 is P over A. P is 20 kilonewton, so 20 multiplied by 10 to the power of 3. And then A is from here, which is 2.4 multiplied by 10 to the power of minus 3. And we just need to do the basic calculation, and we obtain the stress due to centric load is 8.33 MPa. Okay, the next step is we have to find the bending moment. Since the bending moment is due to the load or the P centric load, so M is equal to P multiplied by D. Sorry for that. Multiplied by D. M is multiplied by D, and here the P is 20 kilonewton, so 20 times 10 to the power of 3, and the D is the distance. The figure is like this, right? P is here, so sorry. So the D is 200 plus the middle of this is 40. From here to here, 240. Multiply by 10 to the power of minus 3 because it is millimeter. And we found that the M is 4,800 Newton meter. The fifth step is we have to find the normal stress due to the bending moment. The formula is this: sigma M is equal to MC over I, but we haven't known the I, so we need to find it here. The I is sigma 1 over 12 P h to the power of 3. Why sigma? Because the figure is like this, right? Assume it's rectangle, hollow rectangle, and like this. So we need to find the inertia from this minus this, which is 1 over 12 multiplied by 60 and 80 to the power of 3 minus 1 over 12, 40 times 60 to the power of 3. And we set the neutral axis here, right? So the base is 60 and 40. we found the I, or the moment of inertia, is 1.84 times 10 to the power of minus 6 m to the power of 4. And we put this value to this and find the sigma m is 104.35 MPa. Let me erase this first. So this will be the last step, I guess. This step 6 actually, sorry. This will be 6. Is to find the tensile and compressive stresses, which is at point A and point B, like the question asked. At point A, it is experiencing a tension, so we need to find the tensile stress. While B, it is experiencing compression, so we need to find the compressive stresses. For the tension stress, it is sigma 0 plus sigma m, while for the compression, it is sigma 0 minus sigma m. And for sigma A or sigma T is 8.33 plus 104.35, which is 112.68 MPa. While for the B is 8.33 minus, here the difference is minus. Here, okay, minus 8.33 minus 104.35, which is minus 96.02 MPa. So these are the answer for question number 3. Yeah, that's all for the explanation. I hope you understand what I'm explaining here, and please just give me any suggestion for better explanation or better video next time. See you.